This is the second video in the series for the Unit 2 test review, and I noticed a few people were struggling with this one from the activities throughout the unit. And particularly, these questions, they can't be done in one line, which is what, throws people off. You need to consider more than one alternative. So let's take a look at one here as an option. It says in a co-ed soccer league, teams play each other with the following rules. 6 players have to be on the field. At least 2 members of both genders are present on the field at all times. Okay, so right away, we should be thinking to ourselves, what can we do in terms of a lineup? We could have 1, 2, 3, 4 boys. We could have 3 boys, 3 girls. Let's use G, I guess, for girl instead of W. And then we could do 2 boys, 4 girls, right? Those are the only sort of combinations that you're allowed to do because there has to be at least 2 members of each gender on the field at any time. So the question is, how many different ways are there to pick your starting 6 players? So in these kinds of questions, and one of the ones on the usually this comes around with when it says at least, right? And you notice here that at least 2 members of both genders need to be on the field at all times. So we got to look at these 3 different cases and basically solve them individually and then add them all together. So the first thing we're going to look at is number of lineups with 4 guys, or let's just use boys, make this simpler, and 2 girls. So the number of lineups with 4 boys and 2 girls, okay, what we're going to do there is we have 8 guys to be permuted into, or sorry, to be chosen into 4 spots. So we have, sorry, I'll just use the combinations here, easier. So we have 8 guys, and we're going to pick 4 of them. And then what we're going to do is we're going to multiply this by 6 girls, choose 2 of them. Okay, and this is how, and you'll notice, right, that when you know that you're doing these questions right, when you notice that the top row is 14, because there's 14 players on the team, the bottom row always adds up to how much you actually need to choose, right? I have 14 people and I need to pick a starting lineup of 6. But it's not unfortunately as easy as 14 choose 6 because that would include all the lineups with all 6 girls or 6 guys, which are not allowed under this circumstance, right? So we notice that 8 guys choose 4, 6 girls choose 2. So we'll actually multiply these things now. So I'm going to have to do this sort of along, well actually, so we go 8 choose 4, which is 70. And then we go 6 choose 2 girls, which is 15. And 70 times 15 is 1,050. There are therefore 1,050 different ways of getting a lineup with 4 guys and 2 girls. Again, I got that from 8 choose 4. So all the ways I can pick 4 guys times all the ways I can pick 2 girls, because obviously for every setup of 4 guys I can find, there's going to be all the different ways to cycle through the female players as well. So again, our first one that we did here, let's just make a little bit more space here. The first one that we did, we found there are 1,050 different lineups that have 4 guys. Now there's no way to do 3 guys or 2 guys all at the same time, right? What we're going to have to do is we're going to have to do these individually and add them up. The next one that we're going to look at is 3 guys, 3 girls. We know that this one is 8 guys choose 3 times 6 girls choose 3. Now 8 guys choose 3, 8 choose 3 is 56, 6 choose 3 is 20, 56 times 20 is 1,120. So there are 1,120 different ways that you can have 3 guys and 3 girls on at the same time. To finish this off, we'll do the very last one, which is we do the binomial combination. 8 choose 2 times 6 choose 4. So this time we only have 2 guys and 4 girls. Again, notice every time my top 2 numbers add up to 14, my bottom two numbers add up to 6. And here we have 8 choose 2, which is 28, and 6 choose 4, which is 15, and then we multiply those two together to make 420. And we see that there are 420 ways of having 2 guys, 4 girls. So 1,120 ways of having 3 of each, and then there are 1,050 ways of having 4 guys and 2 girls. So at this point, that question is basically done. What we just need to do is the number of lineups equals, and we just need to add them all together. So 1050 plus 1120 plus 420, which is 1050 plus 1120 plus 420, which is 2,590. Okay, so there are that many different ways that you could pick your starting lineup. Now, what about if we were to do something like, one player in particular has to be on, all the time, right? So how do you do? Sometimes in these questions, she'll say something like, how many different lineups are there if? So we'll say, for number B, how many lineups if Brian is always on the field, and maybe he can be the goalie. Okay, so now we have like a constraint where it's going to limit what we're allowed to do. So in this case, what we need to do is, we still have these same conditions, right? Where there's at least 2 girls, and at least 2 guys. So what are the options we need to look for now? We already have a boy on the field all the time. So what we have now is girl, 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 boy, girl, 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 boy, boy, or girl, girl, boy, boy, boy. And that's the only ones that are left, right? Because basically the idea is now that one person is fixed, is always on there. So we just want to see kind of how that changes. Now, basically here you can see the only thing that really is going to be different is that we're going to be choosing now from a different number of total people. So we're going to say, 6 girls choose 4, which is still the same as before, and then we're going to say it's only 7 guys now, pick 1, and that's all that we need. Okay, so 6 choose 4, which we already found over there was 15. 7 choose 1 is just 7. So there are 105 different ways that you could have one guy on, as long as Brian is always on the field. So if we go through these other ones again, it's not that different. We're just going to kind of just copy this one and just adjust it. So 6 girls pick 3, 7 guys pick 2. That would be the next one that we check. So 6 choose 3 times 7 choose 2 is 420. And our last one here is going to be 6 choose 2 and 7 choose 3. Okay, so 6 choose 2 times 7 choose 3. We get 525 different ways of doing that. Just add them all up there. Okay, and then, so again, 6 girls pick 4, 6 girls pick 3, 6 girls pick 2, and then what goes along with that? 7 pick 1, 7 pick 2, 7 pick 3. Notice that once again, every option, the top adds up to 13, because I've got 13 players to pick from. The bottom adds up to 5, because I'm filling out the remaining 5 slots on my roster. 105 plus 420 plus 525 yields a grand total of 1,050 possible lineups with that one player in a fixed position. So hopefully this is a really, really important idea here, that whenever you're picking things from different groups, what you do is you break them down into the groups that you need, right? So think about that question with the soccer teams, for example. We needed to pick 1 German team, so we do the number of German teams, pick 1. The number of Spanish teams, pick 1. The number of remaining teams, pick 2, right? That's where I came up with that if you look through the solutions. So for this one again, you want to figure out how many total things are you dealing with. Your numbers along the top should always add up to that. Your numbers along the bottom should add up to how many slots you actually have. And if you need to consider more than one case, then do that, because remember, there's no way to figure this out in one line. How many different ways are there to pick a team? Because we have 3 different ways to pick a team, right? Depending on how many boys and girls that we choose. So these ones are really good. I'm going to put out some practice questions underneath that you can try, but I really encourage you to try these ones. They're a very, very important idea, and it can really help you understanding stuff in this unit.